Good day, and today we'll be presenting a final year project that is titled Patient Monitoring System. This is group number 11, DBIT, and I am Roshlin Michael D'Souza, and my team members are Francina. I will take you through the outline of our presentation. First, we will be talking about the introduction and the need of a system, and then we will move on to the proposed solution that we have come up with to solve this issue. Then we will be talking about the learning experiences that we encountered during the development of this project, along with the hardware and software requirements. Then we will move on to the budget of the project that was allocated and the demonstration.
Okay, so now when a patient is suffering from any contagious disease, he or she is quarantined into a separate room. So even in such conditions, certain parameters like the oxygen level, the temperature, the blood pressure, all these need to be kept a track of. And just in order to keep a track of these parameters, the health authority people need to risk their lives as they will have to come in contact with these quarantined patients. So here is where our system comes into picture. Next slide. Okay, so basically what our system will do is it will first collect the data, that is the temperature, the blood pressure, that is the heart rate, and the oxygen level of the patient. And then it will send these data to the Raspberry Pi, where the server is located, the entire server, like the database, then the site, all of it is located over here. Through the node MCU, it will send the data over here. And then from here, the monitoring will be done by the health authority people. So one of the learning experience that we had was previously we made use of the Arduino Uno. Now what happened is we first in the previous sem, we implemented the temperature, the thermal probe for the for temperature and the blood pressure sensor. So when we did and then in the next sem, when we tried implementing the oximeter, that is when we tried connecting the oximeter to the Arduino Uno, we ran out of memory. So we then replaced the Arduino Uno with Arduino Mega, which had a greater memory capacity, because of which the data processing speed also was faster. So the system ran faster, and we even the memory issue that we faced using Arduino Uno was solved.
The second issue that we faced was the ESP8266 and the MySQL connector. So basically the node MCU doesn't have enough processing power to run the MySQL connector library directly, and hence it would constantly crash. To solve this issue, we could use an HTTP post request. The node MCU would perform an HTTP post request to the database. And once this request is performed, it would execute a PHP script on the Raspberry Pi web server that would take the data, split it into its respective variables, and then post the data into the database. Also, along with this, we faced an issue with the MAX 3100 pulse oximeter sensor. Due to its tighter timings of the library, it would not work well with functions that would require a lot of time to execute. To solve this issue, we could use non-blocking delays or asynchronous functions so that it would keep the oximeter running and constantly keep taking reading while other functions are being executed. These are our hardware and software requirements. The Raspberry Pi web server will be running the LAMP stack server, that is Linux, Apache 2, MySQL, and PHP. And the model prototype will be using the Arduino Mega as the main processor, the node MCU for handling Wi-Fi and the oximeter, and the DS18B20 thermal probe along with the BP machine that we obtained from Sunrom with the serial reader. this is the budget that was allocated for our project, with every individual part and its cost. The total cost amounted up to 6,246. So now we will move on to the demonstration of a project. Firstly, we will start with the website that we have developed using HTML, PHP, and CSS.
So this is the registration page. We have two, like we can register, we can make two accounts. One is the a doctor's account, and one is the administrator's.
So once we log in into the administrator portal, we will be dropped into the administrator dashboard. From here, the administrators will first view the total available machines, that is the prototypes that were registered into the system and available. Then the total administrators that have registered and the total number of doctors that have registered into the system.
So here you will get the details of all the of what you entered while creating the account. You can also edit these details that you entered when you were registering from this page.
So this is the user statistics page, which show the list of all administrators that are available and the list of all doctors are available. Administrators can edit the details of any administrator or any doctor using these two buttons respectively. They can also reset the password if required. This is the server.
So
This is
over
the
here, the entire data about the Raspberry Pi, where the server is located. So the details about that is present on this page.
This is the
That's all.
this is the service status, which shows you the various services that are online or offline, along with the uptime and the command and the applications which are using the RAM or the CPU. So now we will now proceed to the doctor's portal.
So since we have already created an account, we are just logging in into it.
So as you can see, there was a check also that was invoked for incorrect username or password.
So here we get the data of how many the number of machines that are already used for how many patients, for the number of patients, and also the number of machines that are still available, which can be still used for more number of patients. So we can also generate a PDF of the report of a particular patient, like from this page.
So I'll just copy the patient ID from here and I'll just paste it over and click on submit.
So if a doctor wants to view the history of a particular patient, so we can generate a report for that particular patient. It contains it contains everything: the temperature, all the readings, along with the prescriptions that were prescribed for that particular patient previously, all of it.
From here, the doctor can view the entire history report along with the prescriptions. In case he just wants to view it quickly for his own analysis, so he can
So
just
these
go
are the
here.
readings that we had taken while we were testing our system. From here, we can add the add if suppose a new patient is admitted into the hospital. So we can even we can add the patient details from this particular page.
From here, the doctors can also can view the patients that have registered into the system, and they can also transfer the patient to another department in case using these two boxes. Here the patient ID will come, and here the machine identifier will come. Every machine identifier is linked to a particular room number and a bed. So the room number and bed number upon transfer will automatically get updated.
As for each room, like each room will have a separate machine. So for that. So here it gives me the details of all the doctors that have registered, the number of doctors and that have registered and have their accounts in this particular server. And even for the administrators, all of these details will be shown in this page.
From here,
So
you can also prescribe medications for the patient using the patient ID, and you can enter the medications that have to be given over here. This gets linked to the patient ID, which is the primary key in our system.
we will now display the demo of our model prototype.
So as you can see, the blood pressure machine is currently on my hand and my finger is on the oximeter sensor. The LCD currently is showing the temperature. So as you can see, the blood pressure machine is taking the reading. So now the reading has been taken, and
It is now
this
sent
reading
through the Node MCU to the Raspberry Pi, where the website is located. And all these readings will be displayed on our website, from where the doctors and the health authority people will monitor. So that was it for our project, and hope you liked our presentation on this model. Thank you for patiently hearing.
Thank you.